From the beautiful South Studios of Way Happy, this is Mr. Meyer and P-1 Graphs and Models. Well, that's right. We're going to start in section P, and that's going to be a little homage to pre-calculus or any other courses you've taken in the past. And we just want to make sure that we're waking up and get everybody on the same page. So what do we have to do in this one? We have to sketch the graph of an equation. We have to find intercepts of an equation. We have to test for symmetry, and we have to find the points of intersection. Not a big deal, right? Something you've been doing since Algebra 1. So let's make sure that we all feel pretty good about it. Now, sketching. What is sketch? So how does this work, by the way? If you're on the Google Classroom, you could go ahead and print out the blank notes and follow along. Or some kids like to write their own notes. They'll just write stuff down and pause the video as it goes. Awesome. Every once in a while, I'll ask you a question. You answer that question, and that's how you get your points and credit for watching the video. So here we go. Sketching this first one. We're going to sketch it. So whenever you are given an equation to sketch, the easiest thing, or I don't know if I should say the easiest, but the one thing you can do is always make an XY chart. You can always say, all right, I'm going to make, this old school XY chart, and I'm just going to start plugging things in. Like maybe I'll plug in x is 0, and when I plug in 0, I get -2. And maybe when I plug in x is 1, I get 1 minus 2 is -1. I plug in 2, I get 4 minus 2, I get 2. So I forgot to write that down. And so you can start to see that what you're graphing looks pretty good. You're like 0, -2. You're like 1, -1. You're 2, 2, and you're feeling pretty good about your graph. Now, hopefully, you notice something missing, right? Over time, we've discovered that maybe if we look at an equation, we can tell a little more about it. This is an x squared. I should expect a parabola. And then the -2 is actually translation, which is down 2. So I should expect a parabola down 2. So it looks like I'm only getting the right side of the parabola. So it'd be smart to try some negative numbers too, like -1. If I plug that in, I get 1 minus 2 is -1 again. And so that brings in this point. And now it's starting to look more like a parabola. And so there you go. Always a great way is plotting points, but it's a horrifically laborious way. And it makes me have to sit here and graph a lot. And there's a lot of chances for mistakes, right? Maybe I wouldn't have noticed that this was parabola. I would have, connected those points and made a line or like a growth graph or something like that. So probably not always your favorite graphing method, but it is definitely a method nonetheless. All right. What about, I didn't mean to do that. What about the next thing we got to talk about is intercepts. So there are definitely some different types of intercepts. There are x-intercepts and y-intercepts. Pretty obvious, right? X-intercepts are when the graph crosses the x-axis. So that means y is 0. That's a good thing to remember, right? Y is 0. So in the equation, put a 0 in for y and solve it. You'll at least get an x-intercept. And a y-intercept is where it crosses the y-axis. And that's when x is a 0. And so, again, put a 0 in for x and find the y-intercept. And probably nothing there that would scare anybody. I'm trying to figure out how to get my mini bar up here while we're talking. There we go. All right, so now you can see some graphs here, the different types of things that could happen where you could have no intercepts. Oh my gosh, look at that. There's one over here on the far right that has no intercepts. There's some over here that have, no x-intercepts, but only y-intercepts, or combinations of everything else. Now, how, again, do you find them? Well, a piece of cake, right? If I'm going to find the x-intercept, then all I'm going to do is make y as 0. So I'm going to have 0 equals x cubed minus 4x. And then I'm going to be like, oh, look, I got to solve that. There's 3 answers, right? Because the exponent. I'm going to factor out an x. I'm going to have x squared minus 4. Oh, I could factor that down a little farther, thanks to all my algebra 2 and pre-calc and everything else. Look at all those different answers. And so what were my 3 answers? Well, this guy says x is 0. This guy says x is -2. And this guy says x equals 2. Now, there's something you got to remember. Those are our x-intercepts. If somebody asked you what are the values of the x-intercepts, you would say 0 and -2 and 2. They're also points. So if somebody wants you to label them, they may label them as when x is 0, y is 0. And when x is -2, y is 0. And when x is 2, y is 0. So you might see it both ways. Some people get really picky about that. Others not so much, right? So it just depends on what people are asking you. And you got to be able to jump back and forth. If somebody shows you just a bunch of points, you got to realize that those are x-intercepts because the y's are all 0. So be super careful. What about that y-intercept that I'm looking for? Well, guess what? I'm going to make x is 0. And if I make x is 0, I get y equals 0 cubed minus 4 times 0, which is 0 minus 0, which is 0. So there's your y-intercept. Oh, I already had that, huh? It was also an x-intercept. Exciting, maybe not. There you go. That's how you find, that's how you plot graphs, and that's how you find intercepts. Let me ask you a question, and I will be right back. Nice work. Now, as I fire this back up, because it did crash on me, as I fire this back up, we have to talk about symmetry. Now, what is symmetry? Symmetry is when you are going to know that the graph is the same on either side of a line or a point. So there are things that we call y-axis symmetry, which you see in the first box. Everything to the right of the y-axis can be copied over to the left side, which makes graphing parabolas really nice, because if you know where the axis of symmetry is, going right through the vertex, all those points you plotted on the right, you can just copy them over to the left. That's so very nice. And if you look here at the instructions, they kind of tell you like, hey, every x and y that you plot, there's a negative x and the same y that will also work for that graph. And that's just nice to know. There's x-axis symmetry. X-axis symmetry, everything above the x-axis gets copied and reflected below the x-axis. So every x and y there would look like, hey, the x would be the same, but the y would change. And that's what that is saying right there. And last but not least, everyone's favorite, the one that we call odd symmetry, is symmetry over the origin. So it does the exact opposite in both directions, or every x and y, if you change them, you get the opposite symmetry. Now, look at that graph. As it goes up and to the right, then the symmetry goes down and to the left out of the origin. The exact opposite. Up and down and left and right, they do the exact opposite. Those are the different types of symmetry. You will commonly hear this one be called odd symmetry, and you will hear this one called even symmetry. So if somebody asks you if it has odd or even symmetry, they're just talking about, does it have y-axis symmetry or origin symmetry? That's about it. So make sure you got that little vocab. Now, how do you do a test for symmetry? Obviously, you can look at the graph. Wow, Desmos comes in great. Your calculator comes in great. But what if you can't have a calculator? What if you don't have a calculator? What if you're just wondering, all right? If you want to do it with algebra, fine, right? That's a super easy step, and you see the test right there. If you want to check for y-axis symmetry, you replace all the x's with negative x's. If you want to check for x-axis symmetry, you replace all the y's with negative y's. And if you want to check for origin, you replace all the x's with negative x's again. Now, that's pretty much what I do. If I'm going to check for symmetry, if somebody goes, hey, is this symmetrical around the, whatever, x-axis, or does it have any symmetries? What I do is I take the original equation and I plug in a negative x. So in other words, I just go over to the equation, and wherever the x's are, I put a negative x in, right? So I just do this. So I took that equation, and I plugged in a negative x. Then I simplify it down a little bit. I go, all right, negative x cubed is still going to be negative. So this is going to be negative 2x cubed. And this negative is still negative, but then it's times that it's going to be positive. It's going to look like that. So that's what this new one looks like. And I go, okay, well, if it's exactly the same, it's called an even function or has y-axis symmetry. If it's exactly opposites, then it has origin symmetry. So let's look. Notice the 2x cubed change signs. Notice the x change signs. So this is saying that when I plugged in a negative x, what I got was the opposite of the original, or what we like to call odd, or what we would call origin, or we would shrink the screen if we wanted and change to a highlighter. Origin symmetry, right? So I can tell you that, does this have y-axis? No, it does not have y-axis symmetry, because f of negative x did not yield f of x. It didn't turn out to be exactly the same when I plugged in a negative x. Did it have origin symmetry? Yes. And why? Because when I plugged a negative x in, I did get the opposite of the function. So that's how you can tell. right? So you can tell that if you plug in a negative x, you can see if you get all the signs change, then you know that it has origin symmetry. All right, what about a point of intersection? The last melon in our review for the first day of calc. Not so bad, right? It says, wants you to find points of intersection. And what does that mean? That just means that you got to find what points satisfy both graphs. Now, we talked about earlier when you plot a graph, you're plotting all the solutions that are possible. We made up values, x is 1, x is 2, x is 3. We plotted them all and we connected them. Those are all the solutions. Now we need to do all the solutions twice. So you could either do that or find some algebraic way. Your choice, right? So I think, here, I'm going to do it two ways. I'm going to do it both because I have time. You're like, no, we don't. Like this one, I could rewrite this as y. If I move the y over and then I move the 3 over, I would have y equals x squared minus 3. That's just a parabola down 3. So that looks like this. And if I rewrite this guy, same thing. I'd have to move the y over and I'd have to move the x over. I would get y equals x minus 1. So that's a down 1, and that's a line that goes like this, right? Boom. So you can see that there's definitely 2 points of intersection. So I need to find 2 points. So just logically, I know there's 2 answers to this. What's kind of nice is what I just did was that I set each of these equal to y, which means through substitution, I could set them equal to each other, and I should be able to solve that. All right. Let's see. Let's get them all on the same side. X squared. Let's see. Minus x. I would add the 1. So minus 2 equals 0. Now, how do you factor that? What two things multiply to negative 2? Remember, you multiply a and c together, the two outsides. And they have to add up to b, which is negative 1. So it has to multiply to negative 2. Has to add up to negative 1. I think that's negative 2 and positive 1. Now I divide by the leading coefficient, which in this case is 1. So I don't care. There's my two factors, x minus 2 and x plus 1. And so if those are your factors, then through the love of the zero product property, set each factor equal to 0. That's why we like things equal to 0. And solve. X is 2 and x is negative 1. Now, is that the answers? No, but it kind of makes sense. I could see like right here at negative 1, it's going to intersect. And at x is 2, it's going to intersect up there. Not the greatest graph, but not bad. And so I'm like, hey, I'm feeling pretty good. Where are those? Well, plug them back in and see. How about plugging them into this one because it looks easy. When x is 2, I get y equals 2 minus 1, which means y is 1, or 1 point of intersection is the point 2, 1. Makes sense. And the other point of intersection was that x is negative 1, so that would be equal to negative 1 minus 1, or negative 2. So the point negative 1, 2 are our 2 points of intersection. So we found it graphically, which Desmos would do by just touching calculator. You could use intersection feature or algebra. We could do the math to figure out where these 2 points of intersection are. That's it. Have a great day. Stay happy, and I'll see you tomorrow.